We are going to this chapter on gravitation. Now, according to Newton, there is a force of attraction that exists between all objects in the universe, whether they are big or small. Now, this force of attraction between the two objects is called as the force of gravitation. Right? This he experienced because he had experienced an apple falling on his head. So he said that the apple fell on the ground since the earth attracts the apple towards itself. Now the earth should also get attracted to the apple. However, comparing the size and the mass of the apple is very negligible compared to that mass of the earth. So we can see the apple moving towards the earth, where the apple moving towards the earth, but not the earth moving towards the apple. Now, thus we have come to Newton's universal law of gravitation, which states that every body in this universe attracts every other body with a certain kind of a force. And this force is directly proportional to the masses of the two bodies. This is one, this is another. It is directly proportional to the masses of the two bodies, and it is inversely proportional to the square of the distance between them. So mathematically, if we have two bodies, one being capital M, being the mass capital M, and another body, say, having a mass of small m, and let d be the distance between them, this force, according to Newton, is directly proportional to the product of the two masses, that is m into m. Let this be equation 1. And this force is directly inversely proportional to the square of the distance between them. Inversely proportional means 1 upon d square, the square of the distance between them. Let this be equation 2. Now combining 1 and 2, we get this, that is F is directly proportional to m multiplied by m divided by d square. If I have to remove the sign of proportionality, it will be replaced by equal sign. I have to multiply it with a constant. This constant is g, which is the universal gravitational constant. So I get this, that is mathematically the Newton's universal law of gravitation as F is equal to g mm divided by d square. Now let me see that what is exactly this g. Now if I consider the two masses to have 1 kg each and the distance between the two bodies or the two objects to be 1 meter, then I will find that everything here becomes equal to 1. So ultimately I get F is equal to g. That means g is nothing. This gravitational constant is nothing but it is a force, alright, of attraction between two bodies having unit masses and separated by a unit distance. We want to look at the units of g. F is equal to, again I look into this equation, F is equal to g mm divided by d square. Alright, I take g on one side, F I multiply it with d square, this d square take it to this side, m into m again comes down, that is g will be equal to F into d square divided by m into m. Now the unit of F force is Newton, unit of d, that is the distance between the two masses, is meter square, and the unit of masses being kg, that is SI. I am taking all the SI unit, internationally accepted units. Now this value of g, we will find that it is 6.67 into 10 to the power of minus 11 Newton meter square upon kg square.